Alright, so we're going to jump into talking about the absolute value function. Alright, so we're going to do a little review here and talk about what the absolute value of x really means. And that's referring to the distance from x to 0 on the number line. So again, the distance from x to 0 on the number line. So when we're looking at the distance from x to 0 on the number line, let's look at some examples here. So the absolute value of 4 is, well, that is actually 4 units away from 0. So it's a positive 4. If we have the absolute value of negative 6, well, from 0, that is 6 units away in either direction. So absolute value, 6 units away. Absolute value of 0, what's a positive value, right? 0. So it's just 0. Absolute value of 1/2. Still just going to be 1/2. It's just the positive of the value inside. And then the distance of absolute value of negative 4.3. So the distance we're going to worry about there is going from 0 is 4.3 away. So positive value of 4.3. Okay, so there's a little bit of review with that. So let's go into graphing one of these guys and see what's going on with that. So we're going to make a table of values and graph the y equals absolute value of x and see what it looks like. So again, this too is the parent function. So this guy right here is the parent function. So everything we do to that equation, we'll move it or transform it around on the graph. Okay. But the parent function is y equals absolute value of x. Alright, so for the values here that we got going in, let's say we'll do negative 3 to 3. So of course, with these, you just get the distance from 0, right? So a negative 3, well, absolute value of negative 3 is just a 3. And for negative 2, it's going to be a 2. Absolute value of negative 1 is 1. 0, we did in our example. Our first example is 0. Absolute value of 1 is just 1. Absolute value of 2 is 2. Absolute value of 3 is 3. Alright, so let's plot these points. See where they're going to be at. So we know we got negative 3 and 3. Negative 3 and 3 is right there. And we got negative 2 and 2. Negative 1 and 1. Our center vertex point right there is at 0, 0. Then we got 1 and 1. And 2. And 2. And then over 3 and up 3 in the positive direction for that one. Now, with that, we're just connecting these dots here. Try to make my line as straight as possible. Oh, we got a little swirly there on that one. I'll go this way. Alright, and you put arrows at the end of it to show that it goes on forever in either direction with that, okay? Now, so looking at our domain, the domain is dealing with our x-axis, right? Dealing with your x-axis. So in that case, we're going to know how far left it's going and how far right it's going to go. Well, it looks like it's going on to the right to negative infinity. It's going to continue to go on and on forever. It's continuously going in that direction. The same thing with going in the positive direction. It's going on forever. A continuous slope of increase, which will go on to positive infinity. So if we're going from negative infinity to positive infinity, we're all real numbers. So you can simply say negative infinity to positive infinity. Again, if you're going to write it like that in your Interval notation, with that, you need to make sure you have your negative and your positive sign on your infinity symbols, or you can simply write all real numbers by drawing the fancy R there. Alright, now if we're looking at the range, we should be looking at the y-axis. So we want to see how far down it goes and then how far up it goes. Well, the lowest point it's going to is 0. So we know, well, let me use a bracket here. It's actually touching 0. So we know it's going to actually touch 0. And then it's going up forever, right? It's continuously going up forever in either direction with that as far as on the x-axis. Now the y-axis is continuously going up forever to positive infinity. So positive infinity is be close by a bracket. So it's interval notation. Or simply because it does stop at 0 and goes all the way to positive infinity, that can be written as simply just saying, or y is greater than or equal to 0. In other words, 0 is a point on it because it's equal to, so that's why we got this bracket on the interval notation, and then y is greater than. So in other words, every value greater than or equal to 0 would describe the range of this function. Okay, so that's the parent function of the absolute value. So absolute value of x is the parent function overall for these types of problems. So look at some examples and see what happens and how the graph moves when we add numbers to it. So with these, we're going to go through here, we'll plot a few points and see how it works out. So in this first example, we have y equals absolute value of x plus 2. And we'll see what happens to it if we make a little table here. So we're going to say we got our x and our y. And let's say we know if we just absolute value of x, if we didn't have this plus 2 on here, we know that that would look similar to our parent function, right? As far as being at 0, if anything, on our x-axis is where the center focal point is going to be, okay, for our vertex. So let's make a point at -2, 0, and 2 on our x-axis. Let's pick 3 points. I know it says plot at least 5 points here. We're going to make that 3. No reason to go away to 5 points. We'll just do 3 points. 3 points should be able to graph it pretty easy. And then we're just going to put these in this equation. So if I put -2 plus 2, which that would give 2 plus 2, so I should get 4. And then if I put a 0 in there, this would be 0 plus 2, so I should get 2. And then if I put a 2 in there, again, this gives me 2 plus 2. So this should give me 4. Let's plot these points. So we have -2 and 4. We had 0 and 2. And we have 2 and 4. Alright, so we'll just draw these lines like this. Alright, so as you can see, that actually moved the center up 2 units. So if it's outside of the absolute value brackets, it's going to move it vertically, up and down, right? So in this case, we went up 2, so our transformation, so I'm just going to write up 2. And with this one, fairly similar on our domain from our parent function, right? We're still going for domain, that's our x-axis, so we're going all the way. We look to the left and to the right from 0, it's going to -infinity to positive infinity. So again, we're still left with all real numbers. Now for our range, with our y's, the lowest value it touches on the y-axis. So if I'm just looking on this axis right here, this y-axis right here in the middle, just looking at that, our lowest y value is 2, and everything greater than or equal to that would work. So as we did with 0 on our parent function, we said our range was from y is greater than or equal to 0. Well, we just moved this dot from 0 to 2. So we can simply say y is greater than or equal to 2. So again, outside of the absolute value brackets is going to have a vertical change on it. Now, this next problem example, we have absolute value of x plus 2. So it's all inside absolute value sign. Now, for this, let's see what points we got here. I'm going to pick the points x and y, and then I'm going to say for this, I'm going to go with -4, -2, and 0. Alright. So if we put a -4 in here, but -4 plus 2, that should give me a 2, right? And absolute value of 2 is 2. Let's say -2 plus 2, well, that gives me 0, right? We're saying like 2 minus 2, which would give me 0. So absolute value of 0 is 0. And then if I was to say 0 plus 2, that would give me 2, and the absolute value of 2 is 2. Alright, so it looks like my center there is at -2 and 0. So -2 and 0 is right here. We got -4 and 2, and 0 and 2. And draw our lines going through those points. Alright. So as you can see here, it actually, instead of moving it vertically, it's moving it horizontally if it's inside of our absolute value signs. So if it's inside the absolute value signs, it's moving it horizontally, which in this case we went to the left 2 units. So we went to the left, I'm just going to say 2 units, okay? Now for our domain, did anything change on our domain? Still looks like it's going anywhere on our x-axis from -infinity to positive infinity. So your domain should still be all real numbers. And what about the setup for our range? It looks very similar to our parent function, starting from 0 on our y-axis and going being greater than or equal to. It's very similar. The only thing that's changed is moved to the left 2 units. So that doesn't affect the range values. So the range is still going to be just like our parent function. Y is greater than or equal to 0. On this third example, let's say we have y equals -2 times the absolute value of x. So in this case, we should be able to use the same points that we did on our first example here to get an overall example of how this should play out, because, well, our vertex should still be at 0, 0. -2, and we'll go 0, and we'll say 2. Okay, so if we took -2 and put it inside here, so we'd get -2 times a negative absolute value of -2, which would be -2 times 2, should give us a -4, because we would have that -2 inside, the absolute value side would turn positive, so then you would have still a -2 outside. If we took a 0 in there, and 0 times -2 is still just 0. If I took a 2 times a -2, let's just say a negative 2 times the absolute value of 2, you would still be getting negative 4. So let's graph these points and see what happened here. Well, our vertex still at 0, 0. We went negative 2, we went down 4 this time instead of up. And on positive 2, we went down 4 as well. So with a negative 2 in front of the absolute value sign, so the value in front of the absolute value sign can determine which way the graph is going to open. Alright, so you determine which way it opens and if it vertically stretches it or if it compresses it. So that could be a possibility with it as well. In this case, we would call this vertically stretching it because it's stretching it, in this case, downwards because it's negative. But if it was positive 2, it would be stretching it upwards. So we're just going to say, though, a vertical stretch. If I can spell here. Vertical stretch. Alright, so that value outside of the value sign, if it's multiplying times it, it would be either stretching it or compressing it. When you have a whole number, it's going to stretch it. When you have a fraction, it's going to compress it. We'll touch on that more later, but just keep that in the back of your mind. If it's a whole number, like the one we have here, and just a negative 2, it's going to stretch it. If it was a fraction, it would compress it. Alright, so with this, the negative then also, so add this underneath here, I'm going to say it flipped across the x-axis, right? So the negative, the vertical stretch, is flipped across the x-axis. Now let's talk about our domain and range. Now our domain, we're still looking at the x-axis, so whether we're going left and right, is it going to stop anywhere? No, we still have all real numbers. It's going on forever in either direction, to the left and the right. However though, for our range in this one, it changes a little bit. So for our range, we're looking at our range here. What is the lowest value? Well, it's going down forever, so it's going to negative infinity. So the lowest point is negative infinity. And what's the highest point? Well, the highest point on the y-axis, when you're looking at just the y-axis here, the highest point is going to 0. It's actually going to touch it. So another way you could write this is simply saying your y values are less than or equal to 0. Or, in the interval notation, you could write negative infinity, comma, 0. The easiest way to write it would be y is less than or equal to 0, though. Short little notation-wise to put that there. Alright, guys. So I hope that explained a little bit on how this works out with absolute value function in the beginning of this, and we'll get more into it and explain a little bit more on the vertical stretching and compressing and the movements of left and right and vertical transformations, and we'll get into that a little bit further on in the next lesson. Until then, hope you learned a little something, and I'll see you next time.